Sustainable Development Goal 7 is to ensure access to affordable, reliable, sustainable, and modern energy for all. SDG 7 focuses on ensuring access to clean, affordable, and renewable energy that is reliable and sustainable, and providing this energy for people across all socioeconomic groups. The biggest challenges in achieving this SDG is the continued use of fossil fuels and the lack of access to clean electricity for developing countries. Low accessibility to improved energy technology is attributed to the interrelated socioeconomic, cultural, and technical factors. Without breaking these barriers and having better integrated economic and social policies, achieving this goal cannot be possible. Many individuals in developing countries, especially in the rural areas, use fossil fuels as a form of cooking fuel. The continued burning of fossil fuels such as coal has led to increased emissions of greenhouse gases that negatively impact the environment, polluting the atmosphere, causing climate change by trapping heat. How do we achieve SDG 7 for all people? Providing renewable clean energy to rural communities requires a multifaceted approach. One solution is the expansion of decentralized renewable energy systems, such as mini-grids and off-grid solutions. Mini-grids, which are localized electricity generation and distribution systems, can be established in rural areas, utilizing renewable energy sources like solar, wind, or hydropower. These systems can provide reliable electricity access to households, schools, healthcare facilities, and small businesses. Off-grid solutions, including solar house systems and portable solar lanterns, offer affordable and sustainable lighting and basic electricity services for individual households. A UV ray detector deployed on a satellite can play a crucial role in achieving Sustainable Development Goal 7 by supporting efforts to monitor and assess solar energy potential, promote renewable energy adoption, and ensure sustainable energy practices. The detector can gather valuable data on UV radiation levels, which are essential for accurately estimating solar energy potential in different regions. This information can guide the planning and implementation of solar energy projects, helping to optimize their efficiency and output. By identifying areas with high solar irradiation, decision makers can prioritize the deployment of solar infrastructure and facilitate the transition to clean energy sources. Moreover, the UV ray detector on a satellite can assist in assessing the performance and maintenance needs of existing solar installations, enabling proactive measures to optimize energy production and ensure long-term sustainability. The job performed by my satellite, which would be performing UV ray detection and monitoring for SDG 7, would be that of a remote sensing satellite or a solar monitoring satellite. Its primary purpose would be to collect data on UV radiation levels from space using specialized instruments and sensors. This satellite would be equipped with a UV ray detector and other relevant instruments to measure and monitor UV radiation patterns across different regions of the Earth. By orbiting the Earth and capturing data from space, the satellite can provide comprehensive coverage and insights into solar energy potential, climate change impacts, and support sustainable energy planning and implementation. The satellite would gather precise data on UV radiation levels across various geographical locations and over time. This information helps estimate solar energy potential, enabling the identification of areas with high solar irradiation for the deployment of solar energy infrastructure. By monitoring UV radiation, the satellite can provide insights into climate change-related phenomena, such as ozone layer depletion and increased UV exposure. This information is crucial for understanding environmental changes, assessing the impact on ecosystems, and formulating strategies to mitigate harmful effects. The satellite can evaluate the performance and efficiency of existing solar installations. By monitoring UV radiation levels over specific regions, it helps assess the output of solar energy systems, identify areas for improvement, and optimize energy production. By evaluating solar installation performance, the satellite can optimize energy generation from solar panels, thereby increasing the adoption of renewable energy sources and reducing reliance on fossil fuels. Monitoring climate change impacts from space allows for better understanding and tracking of environmental changes. Accurate data on UV radiation levels can be utilized to optimize solar panel placement and angle, improving energy efficiency and maximizing electricity generation. In conclusion, the deployment of a satellite equipped to obtain crucial data on UV radiation levels, climate change impacts, and solar installation performance is a significant step towards achieving SDG 7, ensuring access to affordable, reliable, sustainable, and modern energy for all.